Electrofishing is a technique that is commonly used to survey fish populations. An electrical current is passed through the water, which attracts and momentarily stuns fish. If done properly, the fish are not harmed and recover within a few minutes. The fish are quickly netted and placed into buckets, which removes them from the electrical field. They are then sorted and assessments are made, including which species are present, their abundance and density, which is the number of a certain species per unit area, and individual length, weight, and health. In some cases, such as when monitoring for certain pollutants, tissue samples may be collected and sent to a laboratory for testing, or scales may be taken for age and life history classification. There are three types of electrofishing units: boat-mounted, punt unit, and backpack, with the latter being the most widely used. For the Lake Ontario Atlantic Salmon Restoration Program, electrofishing is a very useful tool to assess the survival and growth of juvenile Atlantic salmon in cold water streams. Electrofishing is conducted by some of the program partners. Today we are on a tributary of the Humber River with our partners at Ontario Streams. Ontario Streams is a non-profit environmental organization dedicated to the conservation and rehabilitation of streams and wetlands through education and community involvement. To learn more about Ontario Streams, visit their website www.ontariostreams.on.ca. Today we are assessing a site that is stocked with Atlantic salmon every spring. We are going to assess this site using, you guessed it, electrofishing. We are using a backpack electrofishing model. The unit consists of a 24-volt rechargeable battery and a control box that allows for adjustment of voltage level. Attached to the backpack, we have this pole with a loop on it, which is the anode, and this plain wire, which is the cathode. Electrical current passes from the anode through the water and back to the cathode, completing the circuit. Fish that are close by are attracted to the anode through a process called galvanotaxis, which is the directed motion of organisms guided by an electric field. They will be drawn towards the anode where they can be netted and removed from the electrical field. Electricity and water are a dangerous combination. Electrofishing has the potential to be extremely hazardous, as electrical shocks can be lethal to operators and other crew members. Whenever people are working in water, drowning is also a risk, especially if you are shocked or are wearing heavy equipment. To control and greatly reduce these hazards, there are several safety features located on the backpack unit. There is a red strobe light and audible power on alarm, a water immersion alarm, tilt switch that will shut off the unit if the operator starts to fall over, waterproof internal battery, anode pole operator switch, electrode out of water shutoff, emergency shutoff switch, non-conductive lightweight backpack frame, and a harness with quick release mechanisms. Along with the safety features of the electrofishing unit, we have personal protective equipment, including electrically insulating gloves and waders to separate us from the electrical current in the water, and the use of non-conductive net handles. We also follow strict safety protocols, including proper training and using very clear communication. While we like to have fun while we work, electrofishing is not a time for goofing around, and there is zero tolerance for anyone not following the safety rules. Let's see electrofishing in action. The crew moves along the stream covering from bank to bank. Fish are netted and placed into a pail. On shore, bubblers and frequent water changes keep the water oxygenated and cold. From the pail, the fish are inventoried before being released back into the stream. On this day, we found many species, including long-nosed dace, black-nosed dace, American brook lamprey, brook trout, brown trout, white sucker, pumpkin seed, and largemouth bass. We also found Atlantic salmon, including some healthy par from last year's age class and from the previous year's age class. This tells us that Atlantic salmon are surviving through all the seasons, including the freezing cold temperatures of the winter and, most importantly, the warmer temperatures of the summer. Today's monitoring tells us that this habitat is healthy and provides enough of the proper type of food and cover, acceptable temperature, and good water quality for the survival of juvenile Atlantic salmon. It also tells us that the strain, or genetic makeup, of the Atlantic salmon fry that were stocked at this site are able to survive in this habitat. Thanks for joining us for some electrofishing today, and thanks to Ontario Streams for letting us tag along and for collecting this valuable data. And to our partners, including the Ministry of Northern Development, Mines, Natural Resources and Forestry, for all the research that has improved this program.